African Philosophy Summer School. I hope you can all hear me clearly. I'll assume so. So today, without wasting much of our time, we'll be focusing today's lectures on the links between AI and African metaphysics. So for today's lecture, we are going to be having Dr. Segun Samuel, who will give us our first lecture, which is an introduction to AI. And then we also have Dr. Amarachi Makonam, who will be giving us a lecture on the links between AI and metaphysical personhood in African philosophy. If you notice on the program, there is also a third lecture by Dr. Ojochukwu Abdul, but unfortunately, Dr. Abdul will not be available to present because he is currently indisposed. So the third lecture would not be happening. So today's summer school would end with Dr. Amara's lecture. So without much ado, I'd like to invite our first speaker, our first lecturer, Dr. Segun Samuel, who is currently affiliated with the Global Center for AI Governance in South Africa, to give his lecture introducing us to AI. Thank you very much.
Hi, everyone. It's good to be here. I'll just share my screen and we could start out. So what I'll be doing today is to offer an introduction into the concept or the idea of artificial intelligence. Um, can I get a thumbs up if you can see my screen? Can proceed.
Yes, we can.
Perfect. Great. Um, so I'll do an introduction into artificial intelligence, identify some key concepts. As much as possible, I'll try to make it as rudimentary as I can. Some of them are quite complex. They might stir up conversations that you need to go study later, or I could send, and I think I sent recommended readings that would lay the groundwork for you if you want to get very interested in pursuing, say, a research or pursuing a career in the AI space. Um, and so what I'll try to do is also to lay the foundation for the next speaker, so that they don't probably have to do some definitions around AI and some of the concepts used when we talk about AI. So I'll start with the key question, why we talk about AI and why now. So first of all, AI is a very transformative technology. An example of, we interact with AI systems every day, from our mobile phones to computer systems, our smart TV, to the cars we drive. AI plays a very critical role in how we view the world today. Mm, From Google searches, voice recognition on the mobile phone, Siri, down to facial recognition cameras that operate and manage today's security systems. AI is a very critical part of it all. Not just that, AI is set to rapidly going to change the global economy and the global economic landscape. A PwC study in 2017 estimates that about 15.7 trillion would be added to the world's economy just by having AI systems. Now, to put that in context, the entire African continent's GDP is a combined $3 trillion. That is five times the GDP, over five times the GDP of the entire African continent. And so that's how much of an impact it would have in shaping how we view the world, shaping the global economy, how value is added, how value is interacted with, and all that. Also, it places Africa in a very unique position, right? That's why we talk about it. It places Africa in a very unique position to leapfrog, some of our developmental challenges that we're currently experiencing. And so this is some of the reasons why we need to talk about AI. And also, just because AI as a technology, in fact, all technologies have a way they impact society and shape the way we do things. An example, we think about social media. By simply having or creating social media, it has changed the landscape of how we interact with friends, how we make new friends, how we interact with our work. because now we now have instant communication. We can now informed how we even do commerce. You can actually buy things from WhatsApp messages, buy things over the internet, buy things over Instagram or over like an e-commerce platform. And so this is one of the reasons we need to talk about it. And now is a good time to have this conversation. So what really is AI? Um, in simple terms, AI is the simulation of human intelligence, or a way of ensuring that machines simulate human intelligence, right? There are several key errors in the development of AI that has revolutionized the way we view AI today. But two concepts or two types of AI stand out, which I'll try to explain. One of which is symbolic AI, which is I call it, or it's often referred to as the good old-fashioned AI. That's where you have the GOFA. It's a good old-fashioned AI here. The focus is on logic, rules, and formal reasoning, right? So if you've ever interacted, for instance, with an Excel spreadsheet, you know that you can actually create some formulas in Excel such that when new data is imputed into it, it automatically provides a response to it. So with Excel, you can create a formula for a column and say, every time we add column A and column B together, provide a total score or provide a percentage of the score. That is an example, a very simple example of rule-based systems. And symbolic AI is one type of AI that does that, that it tries to emulate human reasoning. An elevated version of that is what people now refer to as agentic models, right? Where agentic models can go through your emails, create, it reads an email that says, um, we should have a meeting on Friday. If you use an Apple phone, say an iPhone, you'll see that if you use an advanced or say an enterprise version of Google, you have access to Gemini that also does that. So what it means is it can read through the email and then prompt you and say, oh, set up meetings and go ahead to carry out the setting up a meeting in your calendar, and entire workflows are streamlined and simplified. So that's an example of it. It's a rule-based system. Especially what it does is it translates business logic into rules that you can use to build agentic models. The other is statistical AI, which is basically we learn from patterns and data. We'll talk briefly about this subsequently. But what statistical AI sort of is one of the it's a version of deep learning modeling, which with a large pool of data. So an example would be ChatGPT, right? A large pool of couples from like English language. Um, the AI system is now able to predict that after VHAR, the right thing that should follow it should be IS. There is or there are. Um, so there is a ball, there are balls that leap. Being able to do that, you could identify that from a large pool of data over time. So it's an interesting space to find yourself in, where you get into understand the distinction between, say, symbolic AI and statistical AI. Now, statistical AI require a lot of data. Then over time, they're able to learn patterns from this data. And the several dangers to this, the ethical concerns oftentimes that come from statistical AI models, where AI systems could reinforce or perpetuate existing biases in the data that they are trained with. So that's an important thing to keep at the back of your mind. When we talk about AI, at least from a very philosophical perspective, we often talk about the concept of consciousness, the concept of knowledge, the concept of intelligence. And it's important to know that AI systems, what they do is to make predictions. They do not necessarily have an understanding of what they are, interacting with. They're making predictions based on either patterns or logic. And this will be important when we talk about some aspects of AI as they have emerged in history. So in simple terms, artificial intelligence is the technology that makes it possible for AI systems or for machines or computers to emulate human learning, comprehension, understanding, problem solving, creativity, and the like. Okay. And often, like if you see that the image you have on the side there has got AI, so oftentimes we talk about AI, at different times we've understood AI to mean machine learning models. We've understood it to mean deep learning models. Also now speak about AI, we speak about it as generative AI models. So when people speak about AI, oftentimes now they refer to LLMs, like large language models like ChatGPT or Gemini or Claude or from Anthropic or the like. Right? So let me do a quick, very, very brief, in no way incomprehensive take a look at the origins of AI. Right? So ancient Greek and Egyptian societies used to have what is referred to as automatas. And I mean, this also continued down to in Europe, and oftentimes they make effigies or little like um, shaped, crafted mechanical tools or devices, sort of like robots, right? And the idea is that you could do something to these robots and they would work or perform. So an example of an automaton would be like if you played with this toy as a kid, where if you turn all those cars, that if you like you turn a particular button at the bottom and turn it, there's a tension and you want to drop it on the ground, it starts running on its own. Or you have a bird that you turn the keys behind the tail. If you turn it a couple of times and you keep it, it starts to quack and starts to make movement on the table, on the floor. Now that's an example of an automaton. And one of the things that in ancient Greek, somebody referred to as hero of Alexandria, what he used to do would build this, but they'll be powered by steam, right? And for instance, he would do this a steam powered device that create or simulate an automated door that the door just opens on its own. And sometimes they do it, musical instruments come out from mechanical birds and all that. In Egyptian temples, that was also used. Something quite similar done with steam, sand, and water pressure. And that would always give the illusion to people of talking statues, right? So it makes them feel like the gods were saying something. Now, why does this matter, right? It shows, first of all, that for a long time, we've been very fascinated with the idea of artificial life or creating systems that represent artificial life. And the other thing is that automatas, which links very deeply with our understanding of AI, are designed to mimic human intelligence, right? And today we talk about it like in the sense of what AI is. It's just an artificial type of intelligence to simulate human knowledge, human comprehension, human intelligence. Okay. Now there are philosophical roots to AI. So we'll start to Aristotelian logic, and then we'll talk about Cartesian logic, and then the computational bit of it that Gottfried Leibniz actually put into motion. Yeah. So for Aristotle's work, like with his syllogism, and I'm sure some of us, or most of us, are familiar with Aristotle's syllogism. Aristotelian syllogism or deductive reasoning sort of laid the foundation for formal thinking. And I mean, if you're familiar with Aristotle's work, you know the laws of thoughts, which also shaped the way the boundaries around two-valued logic. So an example of Aristotelian syllogism would be all men are mortal, Socrates is a man, therefore Socrates is mortal. That's like a very famous example that we use in syllogism. Now, AI systems rely like on this type of logic to be able to, or what is called logical trees, to be able to make inferences based on rules, right? And this thing is oftentimes is grounded, or it is believed that the foundation of this was this Aristotelian way of logical thinking, right? If you think of the laws of thought, the laws of negation, the laws of excluded middle, and the like, it does help us have a sense of what is permissible or not permissible in logical thinking, right? Now, if you think about the influence René Descartes had on, say, our conception of mind-body problem, right, with the Cartesian meditations, you would it gives us, it lays the foundation for that sort of thinking of artificial life as something that either could be conscious, and if it's conscious, if there's some sort of rationality around it. This also shaped the way early AI thinkers thought about the field and how embodiment, like say robotics, could be slightly different from the critical part of it, the rational part of thinking. And then we talk about Gottfried Leibniz, whose work actually on the calculus of reason actually played a very pivotal part in how we think about computation today, right? Also, this influenced early computer scientists who did significant work in the area of artificial intelligence, and the goal for them was to sort of improve logical reasoning and be able to take very abstract concepts and try to concretize them, right, by creating computational frameworks for which they can operate. Now, in the 1950s, a British mathematician named Alan Turing raised a very, very important question that probably shaped the field of artificial intelligence significantly. His question was simply, can a machine think, or can machines think? Now, that question, I mean, it's got both philosophical undertone and it's got a technical undertone. Like, if that is possible, that led to articles like John Searle's article around the Chinese room, right? Um, I think that was also titled "Can a Machine Think?" That's John Searle's article. It's a very, very profound philosophical article. I think everyone should take some time to read. Now, Turing introduced what he referred to as the imitation game, right? So, which now we call the Turing test, which we're able to see if an artificial intelligence system is able to imitate to a significant degree a dialogue that is indistinguishable from a human, right? John Searle captures this properly in his, conversation around the Chinese room. The Chinese room is basically a thought experiment. For those who are not aware, it's a thought experiment where John Searle tried to say if he was supposed to think of it this way, if you're kept in a room and you do not know how to speak Chinese, but there is a book or a dictionary of Chinese words with you, and you're able to try to write some things, use the words to articulate some ideas and pass it through a hole to someone, let's say someone in another room, who reads it and gives you a reply, and you use the dictionary to decode what the reply looks like. If you're able to carry out, say, a reasonably sized conversation in that, does it necessarily imply that you understand Chinese? So that's the question around, is it possible really for AI systems to think? Do they really understand? They could imitate intelligence, but does it necessarily mean that they understand exactly what they are doing or what they're talking about? Right. And this imitation game, the Turing test, it became like a benchmark for many of the, you know, um, AI scientists and researchers who thought that, oh, like we need to try to build AI systems that could pass the Turing test. Clearly, with ChatGPT and even before ChatGPT and with things like GAN models, like generative adversarial AI models, we got to a point where certain level of intelligence, we had passed the threshold of what we refer to as the Turing test in its most simplistic or most basic form. And we then said the systems were intelligent, but it also didn't necessarily mean that they were able to understand exactly what they were doing or the predictions they were making. They were just following patterns or following rules or identifying an association patterns from data or following rules or rule-based logics that were created for them. Right? So now this technical and philosophical shift by just asking the question, can a machine think, actually helped accelerate the field of AI significantly. From a humanities perspective, it raises both epistemological questions, ethical questions, and even a question around what we understand intelligence to mean, which would be the epistemological bit of it, and how the mind-body problem can exponentially be impacted by just thinking about the possibility that artificial life in this sense is possible with artificial intelligence. If you have any question to this point, please just raise your hand, and as much as possible, I'll try to respond to it. Okay. There are a couple of branches of AI that are talking. I'll just read through this rather fast so that we can get along, and I'll share the slide so you can take some time to look at this more in detail. So oftentimes when you hear people talk about AI, they could use one of several, or they could mean one of several things, and there are a couple of branches that AI plays in. So one is machine learning. So machine learning often is a branch of AI where computers learn patterns from data and improve their performance, without being, explicitly programmed to do that. So you offer them a large pool of data. They're able to look through the data and they're able to make some sort of rational, judgment on that data. This could also be, in a way, it could be rule-based, right? So you could set a rule and say, if you see data like this, categorize them in this column. If you see data like this, I want you to do this and do that with the data and provide a prediction. And that's how machine learning systems are built. Then we have what's called natural language processing. So this is the ability for AI systems to be able to, or to be able to understand, interpret, or even generate human-like and meaningfully human-like conversations. Right? So if you think about your ability to pick up your phone and say, "Hello, Google, could you search for this?" Or, "Hey, Siri, um, look for a music on my phone, play music on my computer." That process for Siri to be able to, oh, yeah, that actually activated my own Siri. Yeah. Okay. That process was of being able to speak to your mobile phone and say, "Hey, generate this," or speak to your computer to say, "Play me a music from YouTube." That process is what's called natural language processing. It's also tightly linked to what is called natural language understanding. So the ability for the AI system to process natural language, make it from speech to text or text to speech, right? That process is what we refer to as natural language processing. Um, Computer vision, on the other hand, is the way computer systems are able to basically see the world, right? Through sensors, telemetric data, and cameras, right? LiDAR cameras to be precise. This is how AI systems get like visual input. So if you have ridden in a Tesla before, or you drive a car that has maybe a camera at the back of the, so when you're reversing, it's able to tell you when you're getting closer to a wall. That ability to figure that out, it's a kind of computer vision, aspect of AI. Even our mobile phones, the ability to take, there's something called computational photography. Now we are able to get, I mean, some of the best cameras in the world that used to cost thousands and thousands of dollars to buy. You now have them compressed in a single mobile phone. And one of the ways that is done is something called computational photography, right? Where you're able to take multiple pictures with different lightings, and it's able to compress it into one, right? That process that the AI system is able to do that is it's studied under the branch of computer vision. Excuse me. There's also there's also robotics, right? Many times when we speak about AI, lots of people focus on robotics. Either they think about an autonomous systems like maybe like Terminator or like a self-driving car or something. But I mean, when we talk about AI, it goes way beyond that. So for robotics, usually these are like physical robot systems that probably, or physical AI systems that are able to carry out tasks, or systems that embody some sort of intelligence, able to carry out tasks and interact with the world, and sometimes independent of humans. We're beginning to see companies like Sanctuary AI, Figure AI, even Tesla build this type of robotic systems. Excuse me. Okay. We also have expert systems, right? I talked briefly about agentic models and what agentic models do at the moment. Expert systems are an example of this, right? Expert systems are AI programs that sort of use predefined logic and rules to simulate decision-making abilities, right? Um, I'm thinking of the simplest expert systems I could suggest. So if you think of a scheduler, like I don't know if you've had this type of stuff where you chatted with someone and then you say, "Let's try to see on Saturday," and then it quickly underlines it, right? And you click on the hyperlink, it goes to your calendar immediately, and it almost creates a calendar, and then you have to go through the process of accepting and fixing the time. Now imagine that you're having a chat with someone and say, "Hey, let's try to have a meeting on Saturday at 9 a.m." And the person says yes, and automatically that is added to your calendar. Usually expert systems, follow this type of kind of logic and rules to be able to create stuff. And they are often dedicated to a field. So you can have an expert system for medicine, have an expert system dedicated, say, to support teachers. They're very, very narrow in the scope oftentimes because they require a lot of domain expertise and knowledge to be able to build it. They're not generalized AI systems in that sense. Then we have fuzzy logic, right, which is another like sort of branch of AI. Here, reasoning is formed that allows computers to handle like very vague, just as the name goes, fuzzy, like the information they receive, it's not very clear, but they're able to exact sort of, or mimic some level of human intelligence that makes it possible for them to still carry out these tasks. I'll give you an example that is very basic. It's not a perfect example for this. So imagine you have a chat with ChatGPT, and in that chat you wrote some things down, but you didn't articulate your thoughts clearly, right? And it was able to ask you a prompt question, say, do you mean this? And it's able to make sense of what you're trying to write and provide you with a response. That's oftentimes is done through like fuzzy logic. Another example would be like if you query on Google and you probably misspell certain things and it feels like Google got it right. You type in a name, you didn't get it when Google suggests the correct response to you and it tells you, I'm searching for this instead of what you initially asked me to search for. That is some form of fuzzy logic, right? Not in the sense that deep, deep learning researchers or AI researchers to talk about it. Another branch of AI which is important to talk about is the neural networks. So neural networks basically is simulating how the human neurons work. Like it was the approach to simulate how the human neurons are formed, how they interact with each other, and how they're able to produce absolutely knowledge, comprehension, and the rest. And we use the neural networks are the bedrock for what deep learning as a way of doing AI was born out of, right? So just basically think of them, they often refer the full name would be artificial neural networks, right? So artificial form of the neurons as they work in the human brain. Good. So the next question we would want to ask, we've asked a question, can a machine think? We need to ask how do machines learn or how like AI systems learn? Um, One of the things that I mentioned earlier is that sometimes they mimic a level of intelligence does not necessarily mean that they're intelligence because what you find is that becomes like statistical associating certain data with approximate data to provide a prediction. There are a couple of machine learning paradigms, right? One of which is supervised learning. Then we have unsupervised learning, we have reinforcement learning, then we also have semi-supervised learning, then we have self-supervised learning, which is sort of like a hybrid approach of, unsupervised learning. Now, supervised learning uses labeled data. So what that means is you use labeled data to train a model, right? So think of the model as a as the artifact of several layers of thinking and processing, right? That's what the model is like the output of it, right? Now, supervised learning is you getting the data as a human and identifying elements of the data to allow the AI system make a prediction. Right? So an example would be, suppose we want to train an AI system to be able to identify cats. What we would do is we would pick a cat and say, hey, this is a cat. We'll pick a black cat, and we'll pick a white cat. We'll pick one with stripes. We'll pick different types of cats. And sure, we'll pick cats in weird positions. We'll pick cats when they're hiding behind, something that looks like a cat that is not a cat. When they're hiding behind the couch, when they're sitting on the couch, when they're on the road, we'll do all that when they're on a tree. And after we have been able to successfully label the data, we then trained the AI system. The training process is basically feeding it this information, and when it gets it wrong, this prediction wrong, we correct it, right? It's a way of this a reward and punishment way of doing it, ones and zeros. Like, oh, this is not what we're looking for. This is a card. So example of this is recapture that we do when we are feeling maybe Google comes up and says, oh, you don't look human. So we want you to identify traffic lights or identify crosswalks on the zebra crossings on the road or identify cars or buses. And then you go through that process of identifying those things. That's a process of like supervised learning. So that process of training these models with labeled data, you have to label the data to identify it. So when you label, you have a category of labeled data. You have another category of testing data. So the testing data is basically, so if we have a large pool, let's say we have 100 data, we have a data set of 100, we split the data set 70, 30, and like say 10. So what we do is that we train on 70, then we introduce it to 30 that it's not had an interaction. Oh, sorry, we introduce 70 and 30 rather. We introduce it to 30 that never had interaction with, right? And it's still able to provide the response and say, "Okay, this is the correct prediction." It's true supervised learning, I mean, that you can identify, like if it's, say we label cats, you should be able to tell a cat as- apart from a lion, even though they're in the same family of tree. You should be able to tell that apart, right? Then we have unsupervised learning, where we don't label the data. We allow the AI system, we will give it all this data and then allow it to make prediction based on the patterns it's able to discover in this. So what happens oftentimes is that AI systems they're very good at identifying patterns in data. So you could notice that lions, cats, tigers, leopards, and all that, they have similar feature. They walk this in similar way. And it will group them under a family of cats, right? And it could do that for cars. It could identify cars and identify different brands of cars based on logos it identifies and those. And that ability to be able to do that and discover new patterns on its own is what you would find in unsupervised learning as the learning paradigms for AI systems. Then we have reinforcement learning. So this involves like a training agent that makes a decision to maximize so think of reinforcement learning as some sort of utilitarian way of working with some AI systems where the training agent, say a human agent who's training the system, will make a decision in an environment that helps the AI system maximize reward. So basically, when the AI system makes a prediction, if it gets it wrong, we say, "Oh no, you failed here. Like, this has to improve it." Like I mentioned, ones and zeros are ways you reward or punish the AI systems. And then when you do that, then over time, the model gets more efficient in ensuring that it provides the right response because it's chasing that reward loop, right? So if it gets it wrong and you punish it, it tries to avoid that. It tries to maximize its response to it. So reinforcement learning, in fact, there's been a resurgence of the talks around reinforcement learning after DeepSeek released their model, largely because they use reinforcement learning to be able to streamline how much data they needed to train or pre-train an LLM. Okay, then we have semi-supervised learning. So semi-supervised learning is, it combines both labeled and unlabeled data. So think of it this way: semi-supervised is that you label a few data, and this time the ratio is smaller data is supervised, and a large pool of data is unsupervised, and you just dump it with the AI system to you combine the method to be able to ensure that as the AI system is making a decision, you're also ensuring that there's some sort of guide for it, right? So you create like an exemplar, like a template to say, "Hey, this is how we expect you to make decision." And one prompt engineering for, say, ChatGPT is a good way to do this, where if you want it to do something for you, you say, "Here's an example of what I want you to do," right? Can you create an example that looks like this? It doesn't have to be the same, but create an example following this pattern. So that's, in a sense, that's how semi-supervised learning is, where you sort of label some data, and then you have unlabeled data that you allow the AI to carry on task with. Then we have self-supervised learning. This is that we basically just leverage data structure to be able to generate labels for this. So self-supervised learning feels it's in a way like unsupervised learning, where we remember supervised learning is you labeling, unsupervised learning is like you're not labeling, you're giving this to the AI system. Self-supervised learning is the AI system acting by itself to actually categorize data in different form and also generate labels for each of these data. Right? It's being used widely currently in AI research, where basically AI models are designed to be able to help label their own data. So before we used to hire human annotators to do that, right? So we had people who would sit down and identify pictures, right? One of the funny examples that they used to do then was they would get people to identify hot dogs, right? So hot dogs are not hot dogs. So things that might look like hot dogs, uh, there'll be a human person identifying it. In fact, sometimes they see very gruesome images that people, because they're taking data from a large pool, they see very gruesome images, and yet there's a human person going through that process of labeling the data. Now, you really do not need to do that. You can get AI systems to do all the labeling of the data and be able to better categorize them. Okay. Do we have any questions before we proceed? We're almost at the end of this, so we can take lots of questions at the end of the talk. Okay. Ilya Sutskever, who's one of the co-founders of OpenAI, and I think he started his own called Superintelligence Safety Institute. Ilya talked about data being the fossil fuel for AI, right? As we talk about how fossil fuel revolutionized the way we viewed, transportation, both for steam engine and even talking about the role that I played for cars and the rest. That's the same role data plays, right? And AI systems require large, massive amount of data for them to be trained on to be able to better make prediction or better make, say, suggestions to people. Now, the absence of that, right? In a case where we are not able to have data, say in very restricted field, like say medicine, for instance, or healthcare, where the access to data becomes restricted, many AI systems are unable to significantly make any form of prediction in that space. So AI systems would require large amount of data. In fact, there's a talk currently in the industry that says that we've exhausted all data forms that we have. And we need to start talking about non-traditional data sources that are trapped in like silos or like within an organization, or data sources that have not been digitized yet. Particularly, you find this in Africa and other low-resource regions where a huge part of the knowledge is either kept in oral tradition or has not been digitized. So there's no digital form of it. It's not structured. There's lots of unstructured data, and not suitable enough for us to like train models with it. So basically, the capacity for AI systems has kind of stalled. So what we are seeing is that if you use Gemini and you use ChatGPT, or you use Llama, which is from that's Meta AI, the gap between them is not as significant as it used to be because now everyone almost have access to the same data sources they train their models with, right? So what gives the edge is unique individualized data or data that has been siloed that is not part of what was used for the training, right? And so that's important to know that data is like the fuel for AI. It's a very, very important part because AI systems run on large amount of data. Also, the current data often excludes the African context. So at least I'm saying this in respect to the CSP members who are here who are on the continent of Africa. The current data we have excludes significantly like African languages. Currently, Africa has about 2,000 living languages, and many of them are likely going to go extinct. And LLMs perform better with other languages, particularly Indo-European languages like English, and the rest, but they don't do very well with the data from non like or what is referred as low resource languages, largely because there is no large corpus to train AI models with. Like so, we don't have sufficient books with text in maybe fiction, non-fiction, in courses like in the sciences, physics, chemistry that we could use to actually train these AI systems in those local languages. So gradually we are losing out on this. But thankfully, lots of African researchers are doing a very good job in raising or doing research and creating ways to preserve these African languages. So the Masakani group are offering open source data sets to be able to use for certain African languages. And now we're beginning to see more small language models and even large language models for dedicated to African languages that have been used to sort of store as a way of preserving these languages. We're also seeing this for cultural preservation. There's a few work around it. There's also a question around, who has the rights to a people's indigenous culture, or like if we give this to a company to train, they literally profit from something that belongs to people at some point. So there's also the ethical question around if we should even give access to say companies to be able to train on this type of very unique data. Also, there's a part around fair compensation, right? If you're going to be making money from an AI model that you built that emulates an African language or culture, at least the people who give you the information, the sages who you interacted with, and the older people who and the custodians of these traditions who you interacted with in the process of training this model, they should be fairly compensated. To create a reward structure for them where they're fairly compensated for the work they provide. So a lot of this is currently a conversation that is going on, at least within the African context. Then there's also talking about the importance of data. Also talk about it's important to talk about how data biases, leads to discriminatory outcomes, right? So data for AI system, when we say data, we don't mean it in the context of internet, having access to the internet or internet data. We mean it in the sense of the material used to train an AI system. Now, data, as Abeba Brian pointed out, data is never without context, right? There's always a context around what a data set would look like. So if we are looking for data of the number of students who have passed an exam, if oftentimes the number of students who pass the exams or the number of students who fail the exams come from a particular group, right? And there might be several reasons for it. There might be that they have learning disabilities. It might also be that they were not thought properly, but it might be that they have foundational issues. They didn't have proper elementary education that impacted their secondary education, that is impacting their tertiary education. It might also be that it's a problem of finance. They don't have access to private tutors after school. And that often meant that, they failed exams. The thing that happens is oftentimes we don't see when we have the data, it just looks like pure number. And everyone says, oh, the data doesn't lie, the number doesn't lie. Here's what it says. And AI systems are very good at being able to identify these patterns, right? So you could say, tell me, give me an example, or let's say we want to hire someone in the hiring space. This is a good example for how AI systems show this. In the hiring space, let's say a company has consistently hired women or consistently hired men, have only had male CEOs for a very long time. If they bring out this resume for the ideal CEO, or they bring out a bunch of resumes and say, hey, from all these resumes, they picked it up from all the Fortune 500 companies in the world, mind you, who have a majority of their CEOs being men and being from, say, particular race, right? Over time, the AI systems, if you train it on that type of data, the AI system is able to identify that the person who qualifies best as a CEO, or the ideal CEO, should be someone who went to an Ivy League university, someone who is of a particular risk type, or someone who's a particular age. And then oftentimes you say that these people are men of this particular age and all. And the reason it's able to do that is that it's able to provide, a prediction based on the training data set that it's had over time. We've seen this with facial recognition, where in cases where they've been wrongly. I mean, at some point, Google was called out for this. With Google, if you typed a particular this thing on Google, if you typed, say, I think the prompt was three black, if you type three black men or something, it would always show people who were on prison uniform, right? If you typed a, a doctor, you only see a white doctor. For a very long time, it was a thing. Like, people called Google, even Google ethics team said, oh no, we need to do something about this. This is a huge problem. And they had to over time fix it. So now if you search like a doctor, you could see a woman in it, because if not, it was only men you could see a woman, you could see a black person, you could see someone of Middle Eastern descent in the picture. So for a very long time, this sort of discrimination that we get from data actually played a key part in how AI systems function. And now we're beginning to have real conversations around the ethical part of it and how we want to guard against potentially allowing AI systems to make decisions that will have huge repercussions on people. Imagine losing out on a job simply because an AI system did not deem you qualified because you schooled in Africa, right? Or because you do not fit a particular mode, you're not male, or you're not representing a particular culture. And so it's important to know that as important as data is, it's not without, some context around it. So there are historical contexts that come into it. And so one of the ways we mitigate this now is when we're training AI models, we anonymize certain things, right? Or we use pseudo identifiers. So they could replace names with numbers, They could replace banks to this when banks are training AI models. They try to replace race to things like gender, things like location. It's not factored into, say, maybe credit modeling. And the reason is because you might put that into credit modeling, and all of a sudden, people who apply from a particular postal code, a particular area of the city, get rejected for loans every time they apply. And they say, I don't know why I just get applied, I got rejected. And the bankers will say, oh, it's not our fault. The system says you're not qualified for this. However, not knowing that historically, the data has excluded people, or the AI system has excluded people from a particular region, or particular group, or particular location. So those type of data now they're anonymized, or even completely removed. So the AI system does not see that. It's not trained with that. And everything that could cause bias, we do what is called a debiasing of the data. So early enough, you're able to identify and quickly see some things that could cause bias in the data and isolate them. Right? Okay. Now, the ethical questions that we might have, or some questions we might want to raise will be, like I mentioned, about bias, hiring or favoring men over women could be one thing. Also, the issue of privacy. Many times people use AI tools now as a way to spy on even employees. So there's a tool, I think it's called Active Tracker, where companies, if they issue your company computer, they have it on it. So if you're supposed to work, say, from 9 to 5, they can tell how many times you leave, how many times you don't use the mouse to move around, or you don't open tabs on your computer when you don't type, and they can tell your typing patterns. They can tell where there's more pressure on your computer. Sometimes the camera takes screenshots of you, right? Even when without your consent, that's some form of surveillance. And governments are also using this with CCTV cameras. They're able to do facial recognition, pick people up, and there's an impact that could have on democracy. That could have on dissent, and people, being able to push back and fight the government. There is also a question of, autonomy, like, when AI systems make mistakes, who takes responsibility? At the moment, much of the law around it focuses on the developers, like the developers take responsibility for this. But over time, so we're seeing how things like that have changed. And then sometimes it's going to be on the user, like depending on how the user uses this technology. So that's a big question, but we'll need to also think about from the ethics perspective. From African concerns, we are looking at I think, a concept referred to as digital colonization. So oftentimes we don't, because AI systems are not mainly built in Africa, particularly the foundation models. So they're very, very important models that, like, we can pre-train and train on. Like, say, the core model for OpenAI that made ChatGPT possible, right? We don't train them here, and which means that we have to depend on, sources like maybe China for like DeepSeek, the US for Llama, for Claude, or for ChatGPT and all that. Our dependency on that raises a huge question, right? Because now we're going to be interacting with this, and they're going to be trained on data that we will no longer have access to, we will no longer own. We lose every form of data sovereignty. We're also going to lose some sort of agency in the process. We've seen some governments in Africa sue Meta or Facebook because they feel that they have been able to access data from people in those countries, and it's a real big problem. That there's been extractive practices that simulates colonization as we knew them, where Africa was just a place for resource collection. And mind you, remember that I mentioned that much of the data required to train AI models at the point, particularly in Euro America, have been significantly exhausted. And there are now private data sources that they're looking out for. And for the continent like Africa, where they've not been models have not really been exposed to much of the data because they're not digitized, they're not structured. Many of them are still in oral traditions. That creates an opportunity for these companies to, anyone who can get into Africa and have access to data early, sort of sets the tone of having a new set of data sets that you could train with. And that is also very problematic because it might create all these extractive data practices that we currently see going on in some parts of the world. Okay, so I'll end with this. what AI, social sciences, and humanities might have in common. So I'm saying this for those who are not particularly philosophers, but in one of the different courses mentioned here. So some questions that you would find like um, AI sociologists ask, who benefits from this, or who is harmed by this, how is this going to reshape society, and how do we prepare for it? Anthropologists will be concerned about how humans will interpret and interact with smart systems, so with AI systems, and the impact that's going to have on our growth as a species. The political sciences will ask about the issue of surveillance and political dissent, and how is AI going to impact governance and smart governance? How is it going to impact how government responds to its citizens? Economics will ask about the importance of the impact of job displacement, job disruption, economic disruption, and even economic growth that AI would have. These are questions also we want to keep at the back of our mind. Those in literature will try to create some sort of maybe write fictions, non-fictions, or create metaphors of how AI and society would operate. Just so you know, Isaac Asimov's book actually shaped much of what we refer to as laws of robotics today. Right? And so literature is a very powerful tool. Some fiction have played a significant role in how we perceive AI today. I mean, we think about Terminators and all that. That's fiction in a way. Okay, philosophy will ask questions about consciousness, morality, free will, and the rest. The arts, we're talking about, even the legality of AI-generated art. What is wrong with an AI-generated art? Is it true art? An AI-generated music, is it true art, or is art in the process? So questions like this will come up. Then history, we'll look at maybe in retrospect how societies have responded to disruptive technology and what that would look like for AI. Yeah, and I end with this note. So you can be part of the AI conversation. First, you don't need to know how to code. You don't have to be a coder. It'd be ideal if you start, getting more technical to understand how the computer, how the technology works. But you also need to ask the right questions. Whose values does this represent? Whose knowledge systems? Why am I seeing what I'm seeing? Especially if you get recommendation on social media. Why am I seeing what I'm seeing right now? Who benefits from me believing this video or not? Right? Then it also translates insights from history, ethics, philosophy into the design process, creating principles for which we could use. And lastly, advocate for equality, justice, and dignity in the tech space. That's one way I think you can be part of the conversation on AI. That'll be all. I'm looking forward to your questions.
All right, thank you very much, Segun, for that very informative talk. The door is now open for questions. If you have questions, simply raise your hand.
Yeah, I think I see a hand. Can you? Is this techno? Can you, yeah, you can ask a question.
And so we have a question from, I think
Yeah,
this is choosing.
yeah, that's good. Consider not too small. Can you hear me?
Yes, we can hear you.
Okay. Thank you very much, Segun, for that technical presentation. And they tried as much as possible to make it simple for us to understand. I just want to have a clarification here. At the beginning, you said that AI is not mainly for understanding or trying to have consciousness like human beings, but just prediction. But along the line where you talked about you said the NLP, natural language processing, it says the ability for computer to understand and interpret. So what does that mean? You said at the beginning it does not understand, but here trying to understand. Just that. Thank you.
So that's a good question. Yeah, sometimes we get lost in speaking. So when I was saying that initially, I was trying to point out that even though it's able to, there's a level of intelligence that AI systems do not have, right? So natural language understanding, as it's used, is focused on an AI's ability to be able to, in quote, understand and interpret human language, right? Including the context around it, the intent. So if you interact on Twitter, for instance, with Grok, you're able to, someone will put a tweet and you say, Grok, what does this say? And what does this mean? And it tells you, oh, this person is referring to a former tweet here, and is able to identify all that. That process for it's in quotes, right? Understanding and being able to interpret human languages, context, the intent behind it, the sentiment in the tone in which the text was sent, right? And it's not just processing the words, it's like I mentioned, in quote, understanding it. Now, when we say we see air system faults on this on many, I mean they keep failing, they claim to understand this, but they keep failing at it. Now I think the big question is it possible for an AI system to be able to have that level of understanding from a philosophical perspective? The answer will be no. Like it's not possible. I think that's where I was getting at. It's unable to understand at a philosophical level when we speak of understanding, right? It doesn't have empathy like we have as humans, right? So there's still a gap in AI's understanding and interpretation of language and subsequent understanding, like how we talk about understanding as humans.
Okay, can I best say understanding in quotes?
Well, that might help.
All right, all right. Thank you very much. Thank you very much.
All right, thank you. A few hands. Christy, you can ask your question.
Um, Hey Samuel, I hope you are doing well. Good to see you again. I don't have any serious philosophical questions. I have a question on debiasing, and I'd like to hear just a little bit more about how this could be done. So, last year I was in Brussels at the AI for Good Center, and we were talking about AI in healthcare and especially for heart attack detection and how these data sets are super biased towards men. So the conversation was, do you augment the data sets? Do you delete certain some of the data? And yeah, and I mean, we've seen how this goes wrong with Google as well in the Gemini project. So what do you think? Like, would it be in the design process, like who would be doing the debiasing? Is it in the collection of the data? Because we don't always have a lot of control there. So yeah, I was wondering, just exploratory. I know there's no like proper answers to these questions, but how would the debiasing of the data sets look ideally, do you think?
Okay, so first, let me just define the concept of debiasing for those who are not familiar with it. So it's a method to identify, reduce, or mitigate, or even completely eliminate unfair biases in data, right? In the data, in the algorithms, or in the outputs that they produce. There's several ways to do it. You could do it before, like you could do it before the training of the model. So one way to do is to get a diverse data set. So like you mentioned in the example you gave, um, it focused on men largely because the data sets that it was trained on was mainly men. So you diversified the data. That's why now, especially with facial recognition, we have more data sets from different people of the world. So if you say, show me a picture of a woman, it would have you put people from different cultures because the concept of woman doesn't necessarily mean just one particular culture. So you have to diversify the data sets, right? The other is also rebalancing. So if 90% of your training data is, say, American English, and you want to add, English from other parts of the world, right? To be able to train it so that at least you try to rebalance the outcome of it. Then another one is to remove harmful correlation, right? So like labels like nurse being a woman, like you want to, when you're training, you want to say, hey, here are pictures of, of men who are nurses, right? Or an engineer being a man. You want to be able to show that, you don't have to do that. Like, and then you can also do it during the training process itself, right? So you can create what is called fairness constraints. So this is like a technical way of doing it. They can also do adversarial training, right? Even when you're testing, also you could do that after you train. You can test this post-processing where you do adjustments and auditing of the system. There are also bias tools, like Microsoft has got its own bias tools. IBM also has a bias tool and all that. Yeah, I hope that helps in a way. Yeah.
Yeah, that helps a lot. Thanks.
All right, thank you, Christy. I'll go to the chat box and then come back to Caitlin. So Ivan is asking, AGI is a poorly defined concept, but I am interested in your take on AGI, particularly how you define it, whether it is achievable, and if you think it is, what needs to be bridged from our current AI systems to get there. Big tech has made claims that it is imminent and they have invested billions to get there. What do you think of these claims?
Okay, so do not quote me on this. Highly subjective view. I'll first start with the definition of AGI. So, for those who are not familiar with it, AGI means artificial general intelligence, right? Um, so it's basically a human-like level intelligence. Think of having the best. You have Albert Einstein or Richard Feynman for physics. Have the equivalent of that for any discipline in the world, and like Nobel level worthy scholars at that level. Now have them being able to carry out human like level intelligence in not just one task, in every single task that you want to do. Achieving the depth in language and reasoning, in creativity, in emotions, in planning, in learning from experiences and all that. Is that fundamentally going to be possible? It is hard. I think we might arrive at some level of super intelligence, but AGI at the moment, I would say no, because there are a couple of things. Being able to do many tasks, which is at least the scope of its ability, might be very difficult because that requires a different level of training. Hence, the need to have that much investment in it in billions and billions of dollars. Then there's also the flexibility part of it. It has to adapt quickly to and then reason, respond. So you interact with it, it has to respond quickly and be able to transfer different skills from different domains. That's a difficult question. The other part of AGI, which I think might be very tricky, is the aspect of consciousness, right? Which is part of the conversation. I think we talk about it in AGI, but not necessarily when people talk about superintelligence. So consciousness, I do not think it's still debatable from a highly philosophical perspective. And again, there are no real examples of AGI. So to your question, at the moment, that's how we know. Okay, Kathleen?
Hi, so I have a question about the adding to the world economy. So you said that there's a excess 15.7 trillion, and I just want to know, like, when we say that that value is added to the world economy, how can we see this benefiting the world? So is it essentially just going to benefit like the top 1% of like, the Elon Musks, the billionaires, or does it have the potential to decrease the widening gap between, uh, poorer nations and richer nations, etc., etc.?
That is a very philosophical question. Um, and it speaks to the heart of the political economy of AI. Sadly, I do believe that it would have an impact on poorer nations. So richer nations are likely going to be richer largely because they are better situated in how they prepare for the possible disruption that AI would come with. Um, for instance, in many developing countries, there's very little upskilling, reskilling that is going on. But you'd see this, like Singapore, for instance, has a training course for citizens over 50 to learn how to use AI systems so that they can also prepare their citizens not to be aware of like risk, like digital clones and like aware of risks of people cloning voices of their children to extort them. The country is prepping its older citizens to be able to use AI. They're creating digital natives who are starting their learning process with AI. Many countries, particularly in Africa, are not like we're not there yet. We have probably other priorities beyond that. So that's a big concern, right? And I feel like it could widen the digital divide as well as widen the economic divide. But in speaking about how it adds to economies, it adds to economy in terms of productivity, right? So you're doing more with less, right? Think about agriculture, right? We're now able to do precision farming. We're better able to appreciate, we know, okay, the land, the constraints of the land. We are able to better know, okay, when do we invest in, or like when do we invest in irrigation? If we invest in irrigation, how can we ensure that this particular small piece of land maximizes production, right? So in that level, in terms of productivity, it's going to help. In terms of creating new products and creating new markets, new jobs, it's likely going to do that. So if self-driving cars come out, then we're probably not going to need, if self-driving cars become more mainstream than they are at the moment, we're probably not going to need more human drivers. However, we're going to have more self-driving car companies. We're going to have more, say, education technology companies, more healthcare companies come out. It creates basically new markets, new opportunities for people. Also, it's going to be like an enhanced decision-making process that is also very important in a way that it adds to society, right? Yeah, so what that means for Africa, for instance, we probably need to start talking about how to wean ourselves off aid and focus significantly on having to grow the economy and preparing citizens, for the possible impact that this would have, and how best we can prepare our citizens to also upskill, reskill, and possibly also look at what the future would look like for jobs and say, hey, if this is going to happen, there might be a need for us to begin to significantly invest in the infrastructure that would support managing a society that is not dependent on having to work. Because if we have robots building everything in factories and we have self-driving cars going through this process, we might need to start talking about universal basic income, and there will be no need to work. Maybe our duty will be like the Greeks. We'll just go enjoy philosophy in a theater and argue and then watch movies or plays and then take a walk by the beach and just have a good time and earn a salary. So again, I mean, we need to ask ourselves, is life going to be meaningful if we don't have work, if we don't have to go to work every day? I think these are some of the questions we need to ask, especially if AI systems begin to take over.
Thank you.
Uh, all right, so the next person, I think I have to step in here. Manuel. Manuel, please proceed with your question.
Right. Thank you. Thank you, Dr. Segun, for the wonderful presentation. I've really enjoyed the way you have taken us through this discussion of artificial intelligence. So I have two questions. The first one is to do with the exclusion of African indigenous knowledge systems in, for example, the information that we get from generative AI, let's say maybe Google Gemini, ChatGPT. I don't know how far you might agree with this argument, but there are a number of papers that are making this argument that African indigenous knowledge systems are misrepresented and largely excluded from the feedback that we get from these generative AI systems. And consequently, this has a number of implications, especially among the Africans that use these systems to get information. I wonder if you have any ideas how best as Africans we can do to go around this problem that whereby we find our indigenous knowledge systems being excluded from these AI systems. And the second one is to do with consciousness. I heard from one of the responses that you have given to one of the questions that was presented you didn't seem to agree or to commit to the idea that currently AI systems could be conscious. So my question is, I understand that the question of consciousness is already complicated in philosophy. What the question, what is consciousness itself? How can we know whether an entity is conscious or not? That is already a complicated question. But considering that there are a number of ethical implications, as well as implications to do with moral agency, moral responsibility, as well as how human beings relate to these AI systems. Uh, I don't know if you would have a general take on whether these AI systems might one day become conscious, if maybe they are not already conscious, or how best do you think this question of consciousness in AI would be addressed, considering the serious repercussions that come from whichever perspective that we have on this issue of consciousness? Thank you.
You're on mute, Dr. Segun.
Thank you for that. Yeah, I was already pontificating. Okay, so one of the challenges I think with our concept of consciousness for AI systems is that consciousness is a lot deeper than maybe we take it for granted because we're humans, and like there's several states of consciousness. There's normal waking consciousness. And yeah, this is particularly important to me to talk about because I wrote a book on consciousness, so I have some of like the faint idea of how difficult it is for AI systems to cross that threshold. So we have normal consciousness, we have altered state of consciousness, we have we have uh, which other level? We have the self-awareness of consciousness. And I think that that's the biggest hurdle. So that is the self-awareness bit of consciousness is where we have the what it is like state, right? Do we ever think we'll get to a point where an AI system knows what it's like to be awake or to be conscious, right? It's a it's a very complicated subject or concept, like the concept of consciousness that I doubt at the moment that the kind of AI systems we have would be able to be conscious, right? They could simulate consciousness, but I doubt it's, I don't know, it's a big it's a big problem to think about. If you want to get into the subject of consciousness and understand it, why it might be complex for AI systems, you should read the work of David Chalmers. He wrote The Hard Problem of, he's the one who came up with the concept of the hard problem of consciousness. And the hard problem of consciousness is actively the part of qualia, like the experiential consciousness, the part of being self-aware, right? I don't think AI systems are able to achieve that anytime soon. So that's why I raised that. To your second or to your first question around what can be done about the exclusion of indigenous languages and indigenous systems. So there's a huge gap already, right? We don't have sufficient data, right? That's what's making it difficult for African knowledge systems to be represented in these AI systems. The other part of it, which I think is like hugely important, is that there's an economic angle to this. These people, or financial angle to it, they need to get into the market with the product and they need people to use the product. I don't think people realize that the African market is not nearly as big as we think it is. The total GDP of the African market cumulatively is about $3 trillion. The US economy alone is $25 trillion, right? There's really no incentive to do anything outside the US economy, the US and maybe Europe, for instance, or Asia. So perhaps what we need is more innovators in Africa, and thankfully we do, right? So Masakani, it's a research community of natural language processing engineers and researchers that have been doing stuff in African languages, right? Building open source translation models for African languages. Lapa AI is in South Africa. They're also doing a lot on languages, building multilingual LLMs. InstaDeep, which was bought over very recently. I can't remember for how much. But instantly, it was started in Tunisia, right, by like some Africans. Africa is also doing a lot on African knowledge systems and knowledge patterns and African languages. There's also the Data Science Network of Nigeria that's doing significant work in like even just building the local competency. And from the Data Science Network, there are many people who are now like startup founders in the agri-tech space, in the health tech space, also in the language space. They created data sets for Nigerian Pidgin, for Yoruba and the like. There's AI for D research that has been support from the IDRC in Canada, supporting lots of work in building data sets for indigenous languages and healthcare. The African Observatory, which I'm also a research fellow of, we do a lot of work supporting some of these initiatives as well. There's several of them. I mean, I can go on their academic projects currently going. UP, Professor Fukusi is leading a data science community, just doing stuff on natural language processing for African languages. So yeah, I hope that answers your question. Yeah.
All right, Bambale.
All right. Thank you so much for your lectures. I had already actually typed the question, but I could just go ahead. The question revolves around policies and laws on AI, especially in, I think, research, academic research, and academic writing. I will just read the questions that I had already typed. I asked that do AI tools remember or share the prompts I provide or use them to train future models? And the other connecting question, I think, is if I use AI, for example, to help me organize and refine my original ideas and thoughts, is the output considered AI generated and no longer original to me? Which means that I would have to, or I will need to cite it. I just want to have your thoughts around the global best practice on AI governance and policies and ethics on academic research and writing. Thank you.
Okay, yeah, that's two very important questions. So yes and no to your first questions. I know that you're able to, for instance, with ChatGPT, which is about the most famous, you're able to identify if you wanted to be able to return certain knowledge. But indeed, it does retain it like by default to be able to help subsequent conversation, particularly if the conversation is happening in the same tab, right? So if you open ChatGPT, you can create new chats and then it catalogs the older one, right? So if you're having it in the same old chat, it has something called a context window. And you're able to, it needs that context of previous conversation to be able to make other predictions and suggestions, right? So that's important to keep at the back of your mind that yes, it does to an extent. If you don't want it to have access to your private data, I think with a paid subscription, you're able to say, hey, I don't want you to use my data for training your models or something, and you're able to get that done, right? It's also I think it was part of the requirement the EU had with part of the EU regulation about data movements with large language models. So that's important to keep in mind. So your second questions, so I think it depends on the institution. So certain institutions do not actually want you to use AI systems to be able to, refine ideas. It is complicated, right? Many institutions have their own policies on the use of generative AI models. Some encourage it. Some say, "Hey, use it." I believe that you should use it. I don't think you should cite it in much the same way using Google to access materials or research resources significantly changed the way we did research. Before, you had to go to a library. Imagine people got their PhD when they had to go walk into a library, read several books. Now with Google, you can just go search for the book and then get there, use word find. You don't even need to read the whole book. There's so many things you can do to streamline that process. And I can imagine that there's some people who are saying, oh, the young people today are not doing good research because they didn't have to go into a library, spend hours trying to search for books, then spend some more hours reading every single page of that book. Now you could use, on PDF document, Adobe PDF, you could just search what you're looking for and see if it's in the book. If it's not in the book, you look for the next book, right? So I think they'll get to a point where we're still in the point of denial for many people to get to the point of acceptance, and then we'll now set rules around how the system should be used. Because one, you want to make sure that the ideas the person is putting forth is original ideas. So many people use ChatGPT to improve the language. They don't have to cite it, and they don't cite it. But yeah, I think it's also up to you or your institution on how these systems are to be used.
All right, thank you. Francis?
Thank you very much. I don't know if you can hear me.
Yeah, we can hear you.
Okay. Yeah, my question is, I think I have many questions to ask, but I'll try to be brief. You say that it is not possible to attain consciousness in machines, but when you're talking about training of machines, that's an artificial machine thing, you mentioned itself, that is self-supervised training. So it means that it's possible for machines to have a self. And then the idea of consciousness that you brought in, that it's not possible for machines to attain that. I know that recent works, especially that by Daniel Dennett, Consciousness Explained, where he refuted the idea of this consciousness using his own naturalistic philosophy. That's purely physicalism. That is what we call consciousness is just the activity of the brain. Now, you brought up also the idea of the self in Chalmers' work. I think I've read that book where you mentioned the subjective experience, that is the problem of consciousness. Nagel also talked about what it feels like to be a bat. I don't know if then that will work. For you to talk about the subjective experience, why don't you think that for you to be a bat, you have to know what a bat is, what it feels like to be a bat. You have to be a bat, just like this subjective experience that is only known to me, which you think AI models cannot have. So I think it's something we should look into because we can't tell if they have these subjective experiences unless we are these machines. So that's the area of consciousness and the self. I am having problems. It seems as if it's somehow contradictory when you say that it's not possible to have a conscious machine and also you say something of itself, training itself without being supervised by any other self-supervisory models. And the other one is the ethical problem of, having this AI.
Can you please make it brief, Francis, so that others can at least be able to ask their
I'm trying,
question?
I'm trying to read, that's why I say that the control problem. When we attain this AGI and maybe we have super artificial intelligence, is it possible? Is it possible to be able to curtail their activities as we think? Because my project was on this super artificial intelligence by Nick Bostrom, where he pinpointed that it would be very difficult to control the activities of the super intelligent entities if we attain it as it's a futuristic project. Then the last one is the self-improvement of AI. When AI starts improving themselves without
I'm sorry to intervene here, Francis. We have so many
okay.
people waiting to ask questions, and Dr. Shegu's time is almost up. So
All
please,
right.
Dr. Shegu,
Thank you.
answer only the first question. The conversation can continue at the chat box or after this summer school. Thank you.
Yeah, and Francis, I mean, really good questions. We could have a chat much later. You could send me an email and then we could schedule something to talk about them. To your question on self-supervised training, first of all, I want to predicate this by saying that oftentimes when we speak about AI systems, in the field, the researchers tend to anthropomorphize AI systems, right? So they use human language to qualify the capabilities of these AI systems. Self-supervised training is basically a machine learning method where an AI model, learns patterns to have more human interaction. And I think that that's important to have more human interaction, that would probably help with managing these sort of expectations from AI systems that they are inanimate in that sense, even though they exhibit some level of intelligence, they're inanimate. Are they necessary or are they, I don't know, there's a philosophical sense in which I think it might be useful to have those level of that type of AI companion, right? There's also a sense in which I I don't know if you think having a soul is important for those physiological needs, then that's a different conversation, right? But I'm aware that there are risks attached to AI systems interacting with humans on very intimate subjects, right? That particularly subjects that they're not well versed in being able to navigate, largely because they don't necessarily, even though they're able to do sentiment analysis, they're not able to understand intent heavily behind it, right? So hence they could suggest to somebody, oh, sacrifice yourself for climate change, not knowing the impact that will have for someone who's already suicidal. So I hope that gives you a sense of some answers. But on the other deeper philosophical question on, yeah, AI systems, so human system lacking a soul, and then what that, I'm not sure I have an answer for you. Yeah.
All right, thank you. I think this is the final one for this session. Amara, please. You're muted. Please unmute your microphone. Amara, can you hear me? You're muted. Please unmute your microphone.
Thank you very much, Dr. Segun, for this wonderful lecture. So my question is this: yes, I have unmuted myself. Can't you hear me? The matter. Can anyone hear me?
Yeah, we can hear you now.
Okay. Okay, so I said thank you, Dr. Segun, for this wonderful lecture. My question is simply this: if we do not understand our own consciousness as humans, so how can we understand whether machines are conscious? That's just it. Thank you.
Okay, that's so it depends on what you mean by not understanding our own consciousness as human. There's significant research done both from a clinical and a philosophy perspective on what consciousness is. And very, very detailed work has been covered on what stimulates consciousness, what is possible, what a wake state consciousness looks like, what consciousness looks like when people are under the influence of drugs, what consciousness looks like when they are sedated. So there's significant medical research in that area, something perhaps that we want to spend some time thinking about and looking at. There are other aspects of consciousness that I think maybe we have not tapped into that might have an impact on how we view AI systems and AI systems' ability to have consciousness, right? And so you're right to that extent. Probably we haven't looked at it in a way, and it shows that there's a gap in the literature that you might want to also spend some time to maybe do that research for us. Let's start talking about consciousness with AI systems in that sense.
All right, thank you so much, Dr. Segun, for your wonderful lecture. I'm sure most, if not everyone enjoyed it. On that note, we draw this particular lecture to a close and we move on to the next. Thank you, Dr. Segun.